So let us look at how we can troubleshoot the generator with the digital multimeter. Like we always say, the appreciation of the various components of the equipment that you need to test is very important, so that you know precisely what to expect from these components as you are carrying out these tests. So we are going to look at the various components of the generator, and we are going to see how they interact with one another to give the overall function of the generator. So now, the generator basically is made up of two major parts. Okay, we have the armature winding and the field winding. Okay, so when we say the generator, we are talking of the alternator section of the complete machine. Okay, that is the part that produces the electricity. So now we just said that the two major components is the armature and the field winding. The function of the armature is to produce the electrical energy that we need from the generator, while the function of the field is to produce that magnetic field that will induce that EMF or voltage into the armature for us to use. So those are the two major components of the generator. So in some cases, we'll have the armature on the stator, that is the stationary part of the generator. So once we have it on the stator or the stationary part of the generator, that kind of generator is referred to as the rotating field generator, because the field winding is on the rotor. So that's why it is referred to as rotating field generator. Then when we have the armature on the rotor and the feed on the stator, that type of generator is referred to as the stationary field generator. But the most common type is, and especially the lower level, that is the lower capacity generators, they are the rotating feed generators, which means that the armature is always on the stator. Okay, so like the electric motor, the stator is wound into three-phase beds. That is, we have three sets of winding on the stator, and these windings, they are equally placed on the stator slots. Okay, 360 at 120 degree apart. Okay, they are equally placed, that is 120 electrical degree apart, each of them, each of these. Each phase is made up of the same windings. Okay, that is the same wire gauge is used to make the windings, and the same number of turns is used to also make the windings. So which means that we expect the same output from each of these windings. Okay, so these windings, when they are placed on the stator slot, they are insulated from the core of that particular stator, which means that it does not have any interactions whatsoever with the stator core. Then the feed winding too, it is also rewound on the rotor core. Okay, also too, the winding is insulated from that particular rotor, as we will see later. So this, what you are seeing on your screen now, is this is the armature winding, the stationary armature winding. Okay, you can see that it's on the stationary part of the generator. This is the stationary part. Then this is the feed winding. Okay, you can see that it is on the rotor. Are we getting it? So it's on the rotor. So this is a rotating field generator. So when you look at these windings, you'll see that there is a kind of insulation that is separating it from the yoke of that is separated from the core of the stator, the stationary part of the. So like we said, this is the stator. If you look at the winding, you will see that they are placed in the slot inside the stator, okay? So the winding does not have any connection, but you can see the insulation between the winding and the yoke. So it does not have any connection with the yoke. If you come to the feed winding too, it is still the same thing. So these windings, they are insulated from this yoke. So it does not have any connection. So when you are using the digital multimeter to test to ground, you are not expected to have any form of continuity to ground. Okay? Now, if you look at this, the rotor, you will see that there is another unit at the edge of that rotor. That is called the exciter armature. This is the exciter armature. It's like another small generator within the generator. Okay, it's always at the front end of the generator around this area. So this exciter armature, its work is to produce that voltage, okay, that will be responsible for magnetizing the field winding. So it is sending the excitation voltage to the field winding, or rather, it's sending the voltage that is responsible for magnetizing that particular field winding to the field winding. So now the voltage that is expected to go to the field winding is supposed to be a DC winding. Well, it's supposed to be a DC voltage, I mean to say. So we have and the voltage that is produced by this armature is AC. So at the back here or at the front there, will show us later, we have the diode rectifier bridge, okay? Okay, it's called the rectifier unit that converts the AC to DC before it is sent into the main field, okay? So if you put that at the back of your mind, this armature produces a certain amount of voltage, which may be 12 or 24 or even 110, okay? But let's assume that it's 12, which means that the output from this armature should be 12 volts. And that 12 volts is sent to the rectifier bridge or the diode rectifier. Then the diode rectifier will now convert that 12 volts AC to 12 volts DC. So what will come out from here now with the rectifier will be 12 volts to be fed into the field winding. Okay, to get more on the operations of the electric that is the generator, okay, how it functions and the various component parts, you can also check out trading on electrical machines, generators specifically. So there, detailed discussion of how the various part functions discussed. So here we are just highlighting the various components, what they do, so that you appreciate it. When you are using that, you are using the digital multimeter, you should know what to expect from that particular component of the generator. So like the other parts too, this part has winding, as you can see, okay? So these windings, they are placed in the exciter armature yoke. Yeah, the slot in the yoke is on the rotor too. And you can see that they are insulated, the windings, they are insulated from the yoke. So when you are testing with your digital multimeter, the winding is not supposed to read continuously, okay? Continuity. does not have any interaction with the yoke. That is, you don't expect the winding to read to ground, okay, when you are carrying out your test. So let us see how they are connected, okay? So this diagram that you are seeing now give us the schematic of the connection of the alternator of your generator, okay? So now, when you look here, you see this is the main armature, the main generator armature, which is this one, okay? So now, here, you expect to get your output. A generator that has neutral, the neutral is taken from this start point, okay? From these three windings, start point of these three windings, okay? So this will be your phase 1, phase 2, phase 3 at the terminal block. So now, when you are using your digital multimeter to carry out tests on the main armature at your terminal block, you will know that since the windings are insulated from the yoke of the stator, it means that when you probe here to ground, you are not expected to have any reading. Probe line 1 to ground at the terminal block, line 2 to ground, line 3 to ground, you are not expected to have any reading. Then when you probe between here and here, okay, what you are doing between line 1 and line 2, what you are doing is that you are testing, or you are taking the resistance of these two windings, okay? Let's say UVW, okay? So you are taking the resistance of the U phase and the U phase and the V phase. That is what you are doing. So when you take the resistance reading, it means that if it is between line 1 and line 2, okay, the resistance you will get will be the same between line 2 and line 3, because you are taking the resistance of two similar coils, and also between line 3 and between line 1 and line 3. So if you are not getting that equal resistance, it means that you have some challenge within the armature. Then if the start point, which is the neutral in this case, maybe you have 4 terminals, okay, 4 lead out from your armature. In most cases, you will have the 6 leads out. Okay, which means each winding, you have 2 leads coming out from each winding. So you do the starring on the terminal block. That will mean that that start point will be accessible to you, okay, to carry out your test. So now, if you look at this, it means that you can take the resistance reading of this winding, okay, and also that is, you place one of your probe, after selecting the continuity, you place one of your probe at the start point, okay, and then you probe line 1, the terminal of line 1, that will give you the resistance reading of the U phase. Terminal of line 2 will give you the resistance reading of the V phase, and the terminal of line 3 will give you the resistance reading of the W phase, okay? So you expect, since they are wound with the same gauge of wire, the same number of turns, okay? That will mean that the resistances of each of them are supposed to be equal. If they are not equal, it means that there is a challenge, okay? There is a problem in that particular winding. So you may not be able to use the conventional digital multimeter to get the accurate resistance reading. In such case, as we explained during our training on electric motors, you will need the milliohm meter, okay? That helps you to read lower resistance, because the resistance of the windings in the armature is very, very low, okay? It's low. At times, you may have it less than 1, depends on the size of the generator, okay? Because the larger the generator, the larger the size of the cable that will be used, and the larger the size of the insulating copper wire that will be used to rewind the coil. So those larger insulating copper wire have lower resistance. Okay, if you use the formula, resistance is equal to rho L over A. Rho being the resistivity, L being the length that you are looking at of the conductor over the cross-sectional area. So the larger the cross-sectional area, the smaller the resistance, okay? So you definitely need measurement device that will enable you to measure lower resistances accurately. So the milliohm meter will assist you in that direction. So that is the armature now. So let's come to the feed section, the feed winding. So in the feed winding, we are going to look at the main feed and the exciter, okay? So this is the main feed and this is its wound here on the rotor. That's the main feed, okay? So when you look at it, we have two sets of coil. This is a two-pole winding. In some cases, you have it four-pole, okay? And the pole determines the speed of the generator. So since it's a two-pole machine, it means that it is a high-speed machine, about 3,000 RPM, okay? So if it is a four-pole machine, that will be running at 1,500 RPM. So let's not go into that now. You can get details of that on our training on electrical machines. So now you see this winding. So like we said before, this winding does not have any interaction with the yoke. So when you probe the terminal, okay, you disconnect the winding leads from the exciter, from the diode plate. Okay, you disconnect the winding lead from the diode plate. Then you can put your digital multimeter in continuity at one end of the lead to your ground, okay? So you don't expect it to read to ground. Then if you read continuity, you expect it to read continuous. That is on the other lead that comes out from the main feed, okay? So lead one, let's say we have lead one and lead two coming from the main feed. So lead one and lead two should read continuity. And if you do resistance reading, you should have some level of resistance. Are you getting it? If it is something that you have been profiling before, which means that during your regular maintenance schedule or during your regular overhaul, you have been taking that resistance reading before, you can now compare your present reading with your previous reading. If there are deviations, that should give you some concern, okay? Because definitely something is developing within that feed winding. So this is the feed winding, and the two leads that comes out of the feed winding, these are the two leads, go straight to the diode plate. This is the diode, okay? This is diode plate. So one end is to the negative terminal of the diode plate. I will show you guys the diode plate later. This is to the negative terminal of the diode plate, while the other end is to the positive terminal of the diode